After you have determined that you have the ambiguous case of an angle side, you need to then determine if you have an obtuse angle given or if you have the acute angle. If you have the acute angle given, we talked about there were 4 scenarios that could possibly occur. And if you have an obtuse angle, then you have 2 possible scenarios. You could either have no triangle or 1 triangle. Determining the number of triangles. 28.6 degrees. I start drawing my triangle. I have a 28.6, that's my beta. Opposite beta is 52.5 for the side, and the nearer side is the 40.1, which is my A. My 40.7, the nearer side, is less than the opposite side of the given angle. Therefore, I know there's going to be 1 triangle. I start setting up then my law of sines, and I need to find out about my height. If this were not, if we had more than 1 triangle, 2 triangles, then I would have to find the height, then I would have to look for some more information. But I know that the side nearer is smaller than the opposite side, therefore I know I have 1 triangle, and I'm just going to start solving by setting up my law of sines. The sine A is the sine I'm going to solve, angle I'm going to solve for first, because I have the side of 4.7. It is equal to the sine of the 28.6 over the 52.5. I'm going to make sure my calculator mode is in degree, and then I'm just going to cross multiply and divide. 40.7 times the sine of the 28.6 divided by the side 52.7 gives me this really crazy decimal. And that's the sine of A. Now remember, the sine of A, we're looking for the angle A, and I need to find the inverse, which is second, and the sine button in my calculator. And instead of typing those crazy decimals, I'm going to just do the blue button, which is the second, and the negative key, and that gives me my answer. Rounding to the nearest tenth, I see that I have 21.7 degrees, 21.7 degrees. I know that in a triangle, all 3 angles add up to 180 degrees. So in my calculator, I'm going to do the 180 minus the answer that I just got, minus the 28.6, which was the given. That gives me 129.7. And if you used the answer, then you're going to get 29.7. If you didn't use the answer, if you rounded it and used the 21.7, you're going to get the 129.6. My students need to be careful about using the rounded answers. I'm not sure about what the rest of the teachers in the world think about that, but you do need to really be careful, because if you're having to round to a particular decimal place and you've rounded and then used that answer, it could, depending on how many times you've used it, give you a round-off error. Setting up my law of sines for the side C over the sine of that 129.7 is equal to 52.5 over the sine of 28.6. Cross multiplying, I am going to put in that 0.7 divided by the sine of the 28.6, and that's going to give me the 84.4 or 84.5, depending on which method you used. On 14, we have gamma, and gamma is just the lowercase Greek letter for C. And in geometry, our geometry teacher said capital C's are opposite lowercase c. So if gamma really bothers you, you can replace it with C. Just make sure on your answer document that you do put the correct letter of the alphabet, and in this case it was gamma. We have the 128.6. We're given the side nearer is 9.6 and the side opposite is 8.2. Noticing that 128.6 is greater than 90, it is obtuse, I look back at my note cards and it says, with an obtuse angle, if the side opposite is greater than the nearer side, we have one triangle and can solve it. 8.2 is less than the 9.6. Therefore, there is no triangle. We've checked. 8.2 is less than 9.6. We're finished. There's nothing to do in that case. The word problems that we're looking at typically are going to be your pilots and your ocean navigating people on the sea. A bearing, when I talk about a bearing is a non-negative angle less than 360 degrees measured clockwise. Now, those of you that have had a digital clock your whole life, starting with the very top of the graph going down and to the right, making our circle is clockwise from due north, and north is right on top where you write your name on your paper. Now we have a scenario where we have NATO exercises, and the NATO exercises, an F-14 Tomcat left the carrier Nimitz on a course with a bearing of 34 degrees. So I'm going to draw my little compass north, south, east, west, and it is traveling on a bearing of 34 degrees. And this is not perfectly 34 degrees, but that is a good indication of 34 degrees. And traveled 400 miles, at which time the F-14 flew on a course of a bearing of 162 degrees. So I'm going to set up my other compass, north, south, east, and west. And 162 is greater than 90, but less than 180 on a straight line. From due north, there's my 162, at which time we have flown in some distance. We're not given a distance, but it is flown at some distance. And finally, the plane flew back to the carrier, and it was on a bearing of 308. So I set up my compass again. 308 is all the way around past the 270 mark, going back over here to the carrier. Okay, 308. Now, it wants to know how far, what was the distance on the final leg of this journey. To find that out and to use my geometry skills, we have parallel lines, and we have cut them by this transversal, which tells me that the 34 degrees is from the side that I traveled back to the north barrier line. To find the angle from 162 to 180, I would just subtract, and that would give me the remainder of that line, which is 18 degrees. 18 degrees. And together, 18 plus 34 is going to give me the entire angle of 52 degrees. The parallel lines cut by the transversal is telling me that the 18 degrees is on the inside. With the bearing of 308 degrees all the way around, all that I need left is this little inside piece. And I know that 360 degrees is a full circle. Subtract off the 308 degrees bearing, subtract off the 18, gives me the inside of 34. Now, what I could do, because I'm needing this side, I have the side opposite this angle, and I have the 52 degrees, and the side opposite it is the one that wants to know how far have we traveled. I'm going to set up my law of sines equals to the amount traveled over the sine of 34 degrees. 400 times the sine of 52 divided by the sine of 34 gives me a distance of 563.7 miles. Don't forget your units.